All right, so I need to start with a bit of a confession. For a long time now, I've had this idea in my head about the shape of the universe, a specific picture. But, it turns out that picture was probably, well, incomplete.
You might remember me talking about the universe as a giant donut, right? A torus. The idea that if you travel in any one direction long enough, you just loop right back to where you started. It's a really elegant concept, but some new thinking has come along that suggests it's time for an upgrade.
So we're basically moving from this simple, easy-to-picture donut to something bigger, and frankly, a lot weirder. And this isn't just a small change. This new idea puts our entire cosmic neighborhood inside a much, much grander piece of architecture. Let's try and build this new shape together, piece by piece.
So what is this new shape? Well, the core idea is that our universe, our little donut, actually exists inside a kind of massive cosmic prism. And it's built from some pretty simple geometric parts.
Okay, I want you to picture this with me. Imagine two cones. But instead of putting them together at their pointy ends, which it turns out would be super unstable, you bring them together at their wide, circular bottoms. They meet face to face right there in the middle.
Now here's the really cool part. Nature kind of hates sharp, infinitely dense points. So the structure wouldn't actually have pointy ends. Instead, it would smooth itself out, forming this beautiful, elongated prism shape with rounded caps at both ends. It's a stable, continuous shape, the path of least resistance.
And get this is where our old friend the donut comes back into the picture. Right at that seam in the middle, where the two big cones meet, a stable, donut-shaped region, a torus, naturally forms. It's like a thick band wrapped right around the waist of this whole prism.
And here's the punchline. That donut isn't the whole universe. It's just our address. It's our cosmic neighborhood. It's the stable, habitable zone of spacetime, where the geometry is just right for time to work properly, for galaxies to form, and, well, for observers like us to even be here talking about it.
Okay, this is an awesome mental model. But it immediately brings up a huge question, right? What kind of physical process could possibly forge spacetime itself into such a weird, specific shape? To even start to answer that, we have to go back, way back, like before the beginning.
The answer starts with one of the absolute weirdest and most important ideas in all of physics. The idea that empty space isn't really empty at all.
It's called the quantum vacuum. And what it means is that on the tiniest possible scales, space is this bubbling, chaotic sea of potential. You've got these little virtual particles and their antimatter twins popping into existence and then vanishing again, all in moments too short to even measure. It's like a constant underlying fizz of energy everywhere. And this is how you get something from, well, basically nothing. If you can pump an absolutely unimaginable amount of energy into that vacuum, some crazy pre-universe state of pure energy, you can force those little fleeting particles to stick around, to become real, stable matter. Energy literally crystallizes into stuff.
So just imagine that colossal energy grabbing spacetime itself. Think of it like a flexible rubber sheet and just folding it, not tearing it, but creasing it into a new, stable shape.
But wait a second. If you've got all this gravity pulling everything inward, why wouldn't it all just collapse into an infinitely dense singularity? Like in the middle of a black hole? It feels like the simplest thing that could happen.
Well, the answer comes from a universal principle. Systems in nature are kind of lazy. They always find the most stable, lowest energy way to exist. And that very process is what can build a whole cosmos out of pure chaos.
Remember how we said nature hates sharp points? A singularity is the sharpest, most unstable point you can possibly imagine. The universe just avoids it. So instead of crunching down to a point, the folding process naturally settles into smooth curves. That's why we get that biconical prism shape. It's just the easiest way for spacetime to be.
Okay, so the shape is smooth. But that just leads to another puzzle. Why would spacetime fold along just one axis, like someone squeezing it from the top and bottom? Why wouldn't it just shrink evenly from all directions, like a deflating balloon?
The answer is something called symmetry breaking, and we see it everywhere. Look at a black hole. Matter doesn't just fall in perfectly from all sides. No, it forms a flat, spinning disk around the middle and then often shoots out these incredibly powerful jets from the top and bottom. The system naturally picks a preferred direction.
And the same principle could apply here, just on the scale of the entire universe.
So you can imagine how this all unfolds over just immense amounts of time. You start with this violent chaos, then things start to settle down. Gravitational waves ripple through this brand new spacetime, and they interfere with each other, creating a stable grid-like pattern. Matter starts to clump together at the intersections of that grid, planting the seeds for the first galaxies and the giant cosmic web we see today.
Okay, so we've built this massive cosmic structure in our minds. Now let's bring it back home. What does all this actually look like from our tiny little vantage point, here inside the donut?
Well, from our perspective, everything would just look like it's expanding away from us in all directions, which is exactly what we see. We can't see the bigger prism structure from in here. And all that spinning we see everywhere, in galaxies and solar systems, that's because spirals are just the most efficient way for energy to move and stabilize itself inside this kind of system.
And this leads to maybe the most profound implication of this entire model. The Big Bang, it might not have been a one-time creation event from nothing. Instead, it might have just been the most recent phase transition, the moment a previous chaotic state finally settled down into this stable prism and donut shape that allows us to be here.
So really, the big takeaway here is that our universe, our home, is this incredibly special place. That toroidal waste of the bigger structure, it's like the Goldilocks zone of space-time itself. It's the only place where the conditions are just right for stable laws of physics to emerge, giving rise to stars, planets, and eventually, us.
Now look, is this model right? Who knows? It's speculative for sure. It pushes way beyond what we can actually test right now. But it's built on real physics, and it ties so many different observations together in such a beautiful way. It's just a great reminder that the universe is probably way stranger and way more elegant than we can even imagine. So I'll leave you with this. What do you think? What does the shape of everything look like to you?